Welcome SYBSC students. Today we are going to discuss about complex variable, and the topic in the complex variable is Cauchy integral formula. That is some examples on general formula of Cauchy integral formula. Example: evaluate integration over c 1 upon z square minus 1 z square plus 4 dz, where c is the circle modulus z is equal to 3 by 2. Here modulus z minus 0 is equal to 3 by 2. 0 is the center of the circle and 3 by 2 is the radius of the circle. Consider in bracket z square minus 1, in another bracket z square plus 1 is equal to z square plus 4 is equal to 0. Therefore z square plus 1 is equal to 0 or z square plus 4 is equal to 0. This gives z square is equal to minus 1, z square is equal to minus 4. Therefore z square is equal to plus or minus I. Here the print mistake, here z only. Z is equal to plus or minus I, and z is equal to plus or minus 2I. Now z is equal to plus or minus I lies inside the circle C modulus z is equal to 3 by 2. This is the circle with center at origin and radius is 3 by 2. Therefore z is equal to minus 1 lies inside the circle, z is equal to I lies inside the circle, z is equal to 1 lies inside the circle, z is equal to minus I lies inside the circle, at which the given function 1 upon z square plus 4 z square plus 1 is not analytic at point these 4 points. Z is equal to plus or minus 2y lies outside the circle. Z is equal to 2y and z is equal to minus 2y lies outside the circle as shown in figure. Now 1 upon in bracket z square plus 4 in another bracket z square plus 1 is equal to 1 upon in bracket z square plus 4 into 1 upon z plus I z minus I, that is z square plus 1, is equal to 1 upon 2I z square plus 4 in bracket 1 upon z minus I minus 1 upon z plus I is equal to fz in bracket 1 upon z minus I minus 1 upon z plus I, where this fz is 1 upon 2I z square plus 4. Now fz is analytic inside on C. The point z is equal to I, z is equal to minus I lies inside C. Thereby by Cauchy integral formula, integration over C 1 upon in bracket z square plus 4 in another bracket z square plus 1 dz is equal to integration over C fz in a square bracket 1 upon z minus I minus 1 upon z plus I bracket complete dz. Separating the integration is equal to integration over C fz upon z minus I dz minus integration over C fz upon z plus I dz. Is equal to, using Cauchy's integral formula, 2 pi I f I minus 2 pi I f of minus I is equal to 2 pi I is common, take outside the bracket f I minus f of minus I. We know that fz is 1 upon 2I in bracket z square plus 4. Therefore here f of I means 1 upon 2I in bracket I square plus 4 minus 1 upon 2I I square plus 4 is equal to 2 pi I upon 2I in bracket square bracket 1 upon minus 1 plus 3 minus 1 upon minus 1 plus 3. 2i is common in the denominator, therefore 2i get cancelled. Pi in bracket 1 half minus 1 half is equal to pi into 0 means 0. Example, we use this Cauchy integral formula only for the points inside the circle, not for outside the circle. Evaluate integration over c dz upon z square into z plus 4, where c is the circle modulus z is equal to 2. Solution. Consider z cube into z plus 4 is equal to 0. This gives z cube is equal to 0 or z plus 4 is equal to 0. Therefore, z is equal to 0 or z is equal to minus 4. The point z is equal to 0 lies inside the circle modulus z is equal to 2. And the point z is equal to minus 4 lies outside the circle. Outside it means outside the circle as shown in the figure. Z is equal to 0. This is the z is equal to 0 lies inside the circle. And z is equal to minus 4 is outside the circle. Take fz upon 1 z plus 4. Then fz is analytic inside and on C. Therefore, by Cauchy's integral formula, general formula, integration over C f dz upon z cube into z plus 4 is equal to integration over C fz upon z minus 0 bracket cube dz is equal to integration over C fz upon z minus 0 raised to 2 plus 1 dz. F dash z is equal to, therefore f dash z is equal to minus 1 upon z plus 4 bracket square dz, and f double dash z is equal to 1 upon z plus 4 raised to 4 2 times z plus 4. Derivative of z plus 4 bracket square is 2 times z plus 4. Minus minus becomes plus is equal to z plus 4 will get cancelled. 2 upon z plus 4 back in bracket z plus 4 bracket cube. F double dash 0 is equal to 2 upon 0 plus 4 bracket cube is equal to 2 upon 4 cube is equal to 2 upon 64 is equal to 1 upon 32. Therefore, from equation 1 we have integration over c dz upon z cube into z plus 4 is equal to pi I cross 1 upon 32 is equal to pi I upon 32. Example, this is by using Cauchy's integral theorem. Evaluate integration over c dz upon z plus 4 bracket square dz, here double dz, therefore integration over c dz upon z plus 4 bracket square, where c is the circle modulus z minus I is equal to 2. Solution. Here c is the circle, center at z is equal to I and radius is equal to 2 as shown in the figure below. Z is equal to I lies inside the circle. This is the circle with center I and radius is 2. Here 1, 2, here 1, 2, radius is 2. Here C is the circle, center at Z is equal to I and Z radius is 2 as shown in figure. Consider z square plus 4 bracket square is equal to 0. This gives z square plus 4 is equal to 0. Therefore, z square is equal to minus 4 or z is equal to plus or minus 2i of which z is equal to minus 2i lies outside the circle modulus of z minus I is equal to 2. Z minus 2i, z is equal to 2i minus 2i lies outside the circle. Now, here the example like this is here z square. Now, the integrand 1 upon z square in bracket 1 upon in bracket z square plus 4 bracket square is equal to 1 upon z minus 2i in bracket z minus 2i z plus 2i bracket square is equal to 1 upon z minus 2i bracket square, z plus 2i bracket square. Take fz is equal to 1 upon in bracket z plus 2i bracket square. Then fz is analytic inside and on C. And z is equal to 2i lies inside C. Therefore, by Cauchy's integral formula, integration over C dz upon z square plus 4 bracket square dz. Here double dz, avoid this one dz, is equal to integration over C fz upon z minus 2i bracket square. Therefore, fz is equal to z plus 1 upon z plus 2i. Here 2 pi I upon 1 factorial. Using general formula of Cauchy's integral formula, f dash 2i, but fz is equal to 1 upon z plus 2i bracket square. F dash z is equal to minus 1 upon in bracket z plus 2i raised to 4 into derivative of this 2 times z plus in bracket z plus 2i. Z plus 2i 1, z plus 2i get cancelled, is equal to minus 2 upon z plus 2i bracket cube. Therefore, f dash 2i is equal to minus 2 upon 2i plus 2i bracket cube is equal to minus 2 upon 4i bracket cube is equal to minus 2 upon 64 minus I is equal to 2 in the numerator 2 cancel, in the denominator it becomes 32 1 upon 32 minus becomes plus 1 upon 32i. Substituting f dash 2i is equal to 1 upon 32i in equation 1 we get here is equal to 2 pi I upon 1 means 2 pi I into 1 upon 32i is equal to pi by 16. It's okay, we stop here.